Hey, what's up everyone? This is going to be a video on Tensorboard, and what Tensorboard is a tool that lets you visualize and really see what your network is doing. Deep neural networks and convolution neural networks and recurrent neural networks, they're always been sort of a black box for what is going on, and Tensorboard allows you to poke in and peer in to see exactly what's going on. So what I'm going to do in this video is I'm going to explain how to use it, how to get set up, and we'll use an example code that I found from the Tensorboard Dev Summit from this year. So a few points to add. If you have if you have TensorFlow, then you have Tensorboard. It comes in the install, so we don't need to go and install anything else. Number two is don't cheap out on your graphics card. So I have a GTX 950, and I was trying to run the example code, and I was getting error after error, blast, segmentation error, all sorts of stuff. Was googling it, spent hours and hours like trying to figure it out, couldn't figure it out. Then I switched over to my laptop, which has a Quadro M2000 with 4 gigabytes of video RAM, and everything ran smoothly, no errors, no problems. So I suspect the my card with 2 gigabytes was just not cutting it. So I'm gonna get a new one, something a little better. So I highly recommend getting something a little better. Go for the 1050. I think it's got 4 gigabytes. So 4 gigabytes or more should be good enough. And then the next bit of caution is to be careful with your paths. So I've noticed that with Windows, the paths that are in the example codes, like the way they say to create this temp directory or locations for these files, it's a little tricky and was throwing errors. So yeah, most of the example code was probably from users on Mac and Linux, and that works on theirs, but for Windows users we have to make some changes, so just a bit of caution. So first thing to do is I started with some example code from this guy Dandelion, who he works on TensorFlow and Tensorboard. So what I recommend is go to YouTube, check out his video. He does a whole 30-minute talk on it, explains all this stuff way better than I can. And if you go in there, there's a comment with a link to his GitHub with a gist that has the example code that he used. So yeah, go to the video, find the link, go to his gist, and come down and yeah, download it. So if you go to it, this is his page here. The top one is this big thing is labels. So scroll down. Scroll down to this MNIST.py, and yeah, copy that and bring that over to blank one. So let's see. Oh geez, I started running it. Probably gonna get an error with this. Well, let's see what it does. Okay, yeah, good. URL lib error. So yeah, copy it into a new file, and we're gonna need to make some changes because this won't run like you saw on our system. So the first thing you got to do is let's see, URL lib. If you're on Python 3, this will give you an error. So what we want is from URL lib dot retrieve or dot request import import URL retrieve. Yeah, that's what we want. So yeah, make that change. And then here we get rid of the URL part, URL lib part. Just make it URL retrieve. Another thing is at the end of the website, you need to add a / because yeah, you'll get an error there too. And then another thing that you need to do is this log dir. So what this does is it will create a temp file. So in your current working directory, it'll make a file called temp and then another file called MNIST_tutorial. But it'll throw an error because this / like, I don't know, it throws an error. So what I did was I did this in a bunch of places. I did it here, here, and I forget where else. So I'm gonna go to the file where I did it, start at the top. And okay, yeah, I did it here for line 23 and on that log dir. And a side note, I'm using Atom, and then I have this mini map and I have the word highlight on. So, and I also have the mini map highlight on. So I can highlight the word, puts the box around it, and then I can see where it is in the mini map. And I can scroll to it. So I have that thing here. Don't have it here. Have it here, line 121. And that's it. Yeah, so what that's doing is it's just taking this slash off. You can see in some spots I didn't take it off because it, like, in those spots I needed it. And I was playing around with this for a while, getting lots of errors. I tried using os.path.join, still getting errors. So that's why point number 3, be cautious of your paths, because I don't know, these paths are all weird. Anyways, I think that's all I did. Then I ran it, and I'm not going to run it here because when I run it, it fails. So what I did was I ran it on my other computer, and I just transferred the files over here. So once you run it, it's going to create a bunch of files, a bunch of save points for Tensorboard to go look at. So before we go open up Tensorboard, you need to go to the projector_config.pbtxt file, and this thing is like some paths for the metadata and the images. So if the way this is, when you run it, it's gonna be like this will be like, that'll be gone. And also these slashes, I think they're /, and there won't be 2 slashes per. And then, so if you try and open up Tensorboard, it's gonna read this file, try and go to those paths, and then throw an error saying, oh, these paths don't exist, or these files don't exist. So what I had to do was put the absolute path instead of just some path from the current working directory. And then I had to make them /, and I had to make them double /, and then it finally worked. So yeah, again, these paths will trick you up. So yeah, you have to, just give it the absolute path, give it /. It's probably a Windows thing, so I don't know. Maybe if you're on Linux, it's not the case, but so moving on, the other thing is this labels_1024. When I opened this thing up in Notepad, it was just like, gibberish symbols, and so I think this might have also caused an error. So what I did was I opened it in Excel, and then I just resaved it as a .tsv file. And then when I opened it back up in Notepad, everything looked okay. So you might need to do that. I'm not sure if it caused a problem, but yeah, if it can't like read this thing, then it might throw an error. So it's just like a column that has the label for what the image is. And then the last thing is check the sprite folder or the sprite image. So what this is this is going to be the actual like image labels that will go onto each point in your embedding portion. So if this isn't right, your embedding it won't have the labels, and you really want the labels because then you can really see what each data point is. So yeah, check to make sure this is there. You're downloading it just straight from the site, whatever that address is, this gist site. So yeah, check for that. And then, so yeah, I think that's it. So yeah, in case I didn't mention, this is a model that's using MNIST data, the handwritten digits 0 to 9. And yeah, so it's learning and then training, and yeah. So what the code is doing is it's creating all these save points, and it's saving like, I don't know, stuff with the layers. So you're giving a name to the layer, and then the model is so the model is like saving these layers at different points. So there's an embedding item, and there's this thing called saver. Yeah, I'm not exactly like well caught up on this, so that's why I recommend watching Dandelion's video. He goes a lot more into it and explains it way better. So yeah, so just watch that. So now once you've run this and everything's all good, you come to, let's open up a new command window. So what you'll do is you'll type tensorboard --logdir equals, and then you give it the path to your data. So let's see, I have it here. You can just go to the temp directory, paste that in there, and if you want, you can add the debug flag. That actually helped me a lot when I was struggling, because it gave me some clues on why the paths were screwed up. So if you're having problems, just add the debug flag. It might help you. So you run it, it loads all those CUDA libraries and stuff, gives you a website address, and so then you can just open up Chrome, and you can just go to localhost 6006, and then, or you can use this that address that it gives you. The only thing, like on Windows 7, it would throw an error. It would say like this site doesn't exist. So then I had to use the localhost 6006, and then it worked. So anyways, this will bring you to Tensorboard. So there's a few things at the top: scalars, images, audio, graphs, distributions, histograms, and embedding. So I'll start with scalars. You can see plot of the accuracy, and accuracy 0.2 seems bad. But anyways, it gives you the accuracy. Like I said, I just copied this from the GitHub site, so maybe I gotta tweak it. So yeah, here's accuracy and xent. Yeah, and the image tab provides like 3 images of 0, 6, 2. I don't know. It's just to make sure that you're not like getting nonsense, and just a sanity check. Audio doesn't work. I'm not sure if you did have audio, if it would work, but yeah, so nothing there. The graph's kind of cool. It like I said, it shows you how the data is flowing between the layers. So yeah, I'm not exactly sure how to interpret everything, but it is pretty cool. So maybe when I study and get a better idea of what it's actually doing, I'll make a video that explains it. But you can go into these little boxes and you can get get even more and more details and going. So that's pretty cool. You can even download a image of it. So then there's the distributions, and so this is each layer in your model. So this is the activation, bias, and weights for time for each of the 4 layers, which is kind of cool. The histogram is more of, it's almost like the distribution, but it has like this depth. I'm not exactly sure what the depth is, but it looks pretty cool. So yeah, activation, biases, weights for all 4 layers. There's different modes. So there's wall, and there's relative, and then there's overlay, which like flattens it out a bit. So I think the offset looks cooler, but yeah, anyways, so the coolest part is the embedding by far. So if your PBTXT file has the correct paths, and you have a sprite file, and you have your labels correctly, then when you click on embedding, everything will look correct. So what this is the 3-dimensional space that yeah, it's displaying the, I guess this is the test data. So this is a set of 1024 of the MNIST of these little images projected onto this space. And because we have that sprite and that label file correctly made, each point has the image on it. So yeah, so you can pan and you can zoom, and in this view, this principal component analysis view, there's like, I don't know, 10 principal components for the 10 dimensions of this data set. So you can play with these. I'm not exactly sure how to interpret it, but yeah, it looks cool. But the coolest is the TSNE, the distributed stochastic neighbor embedding. So what this does is shows you like the evolution and the grouping of the data into the 10 dimensions that it's grouped in, but except it's projected onto this 3-dimensional space. So yeah, you get this really cool like animation. So I'll show you it right here. So yeah, all the things are grouping and moving into their like areas. So let's see. Oh yeah, and also what's nice is there's a coloring, so you can color the groups. So yeah, it's just easier to see, not just by like reading the little letters on it. So yeah, it's it should be grouping into their like, you know, into their proper groups. So all the zeros should go together, 2s, 3s, 4s, etc. There's a few parameters that you can play with. There's the perplexity and the learning rate. So learning rate will, like, they'll move faster, but I'm not sure if like the clustering and the grouping will be poorer. So you can see there's some stuff going on in this group. So it's mostly 1s, but then there's like some 3s and 7s floating around in there. And there's another group of 1s down here. There's this 2 kind of mixed in with these 7s, and this 8. So yeah, maybe with playing with these hyperparameters, you can get different results. So I don't know. Let's try rerunning with the different perplexity and learning rate. And yeah, you need to get to a few thousand iterations, I think, before everything is all nice and grouped properly. And it's not necessarily that this region represents like the 2-dimension and this represents the 6-dimension. It's more complex than that, and I don't know exactly all the details, but if you want to read more onto it, you can go to the TensorFlow website. So there's a section called Tensorboard embedding visualization. So they give some more talk on it, how the tool works, and then there's also a link to another article that goes into the TSNE more in depth. So I recommend going there, reading more on it. Explains what those hyperparameters do, and it also you know, it has the stuff built in so you can like play with the stuff on the fly. Just a lot more info. So check that out. There's links to these people who worked on it, so you can get even more info. So yeah, I think that's it. So let's see. Let's just go over the points again. Go back to my points here. So yeah, Tensorboard, you don't need to download anything. As long as you have TensorFlow, you have Tensorboard. So so yeah, if you've got TensorFlow, use it. And yeah, another thing, you know, don't cheap out on the card, because you might, you know, get stuck like me and not be able to use it for a while. And then be cautious of your paths. Like I said, check your paths, make sure your code can run, and then once you get it to run, check that pb.txt file, specify the absolute path. If it's like, if you're getting that no file error when you load the embedding, and use the debug flag. So that was helpful when I was trying to get the embedding to work. So yeah, if you have any questions, just leave a message. I'll try my best to get back to you and help you. And yeah, that's it. I'll you know, be back with another video later. See ya.